Let's look at differentiation of vector valued function. We define the derivative of a vector, r prime of t, to be the limit as t approaches 0 of r of t, r of t plus delta t minus of r of t over t for all t. If it's r prime of t exists, then r is differentiable. You can see this is the same definition we used at the beginning of the year. The difference is on these we will be breaking them into components. So if r is f in the I direction plus g in the j direction, then r prime of t is f prime of t at I, or in the I direction, plus g prime of tj. The rules, properties of derivatives that we studied at the beginning of the year all apply. If I take the derivative of a constant times a vector, then that's the constant times the derivative of the vector. I can add vectors and take the derivative. I get the sum or difference of the vectors, of the derivative of the vectors. If I have a product of two, then I need to use the product rule. So you see these are pretty much the same thing, whether I'm multiplying by a function of t or another vector. Now, cross products, we're not really going to cover this, all right, but it's really a cool thing. We're probably going to do it at the end of the year. Now, suppose I have a vector valued function, and r is cosine I plus sine j plus 2tk. Find r prime. So r prime, derivative of cosine is minus sine. Derivative of sine is cosine plus 2k. To find the second derivative, derivative of minus sine is minus cosine. Derivative of cosine is minus sine. Now, this is 0, so I'm just going to leave it off. Another example, to find these derivatives when it's something a little bit more complicated, or maybe not. R prime is 2ti, and I'm just going to leave off the j term because it's 0. What is this one right here? So this is minus t to the negative 2i plus 1 over tj plus 2e to the 2tk.